Hello, and welcome to the third module of the Sharp Smart Windows Collaboration Display course. This module is designed to be a step-by-step guide to navigating the Windows Collaboration Display from Sharp. We'll be outlining the essential features found on the front and back of the device, as well as providing an overview of the user interface. This is the Windows Collaboration Display from Sharp. The 4K camera and IoT sensor hub are to be mounted on top of the device. When facing the Windows Collaboration Display, the hardware buttons are found on the right side of the lower bezel. Moving from left to right, there's the Input button, the Main Menu button, the Microphone Mute button, and the Speaker Mute button. Next are the Volume Controls buttons, Volume Up and Volume Down. And last is the Power button. Throughout the lower bezel, there are 4 indicator LEDs. These indicate the currently established connections. From left to right, the LEDs are labeled USB 1, USB 2, HDMI, and Wi-Fi. The Windows key is located at the center of the lower bezel. The passive pen, included with the Windows Collaboration Display from Sharp, can be stored on the pen trays located on either side of the LED indicators. The pen magnetizes to the pen trays for quick access. Lastly, a USB Type-A port is found on the left side of the lower bezel. This is the back of the Windows Collaboration Display. Here, users will find 2 USB-C inputs, labeled 1 and 2. Next is a USB Type-B input, and then an HDMI input terminal. Just above those inputs is a standard VESA mount, which can be used to mount a PC to the device. Now, the 4K camera. It has an optical audio cable, a line-in audio input, and a USB Type-3 connection. The optical audio cable and USB connection have dedicated ports further down the device. The last set of essential connections are found on the other side of the Windows Collaboration Display. There's a USB-C output port, a USB port for storage expansion, an internal computing terminal, a line-out audio output terminal, an external source terminal, and 2 USB ports for the IoT sensor hub. And finally, just below that section is the main power switch. That was a quick overview of the Windows Collaboration Display's external features. Next, a tour of the user interface. This is the home screen. It's the default screen displayed after launching the Windows Collaboration Display. The home screen includes the instruction panel, the action panel, and the action thumb. The instruction panel is found on the left side of the home screen. Users can select individual instruction buttons for directions on connecting devices. Each button also indicates the connection status of the source. This panel is broken down into 3 separate sections. Under Ready to Connect is the device name that users will connect to when they cast wirelessly via Miracast. The wired and wireless sections indicate the status of possible device connections within each box. If the USB-C, HDMI, or Wi-Fi icons are green, then the connection is active. Selecting an active connection will display the external source. To return to the home screen, push the Input or Main Menu button on the lower bezel to bring up the action panel. Then, select the Home button. The action panel is the device's main control bar. It contains the Input, Settings, Sensor Hub, Home, Back, and Hide buttons. The Input button opens the Input panel, where users can manipulate external display sources. The Settings button opens the Settings panel, where users can access customizable features and functionalities. The Sensor Hub button launches the Sensor Hub showcase. As demonstrated, the Home button can be selected at any time to return users to the home screen. The Back button lets users navigate to previous screens within the on-screen display, and the Hide button collapses the action panel into the action thumb. On an external source, this button can hide the action panel and on-screen display completely. The Action thumb is a smaller version of the Action panel. It's present at all times so that users can access the Action panel from either side of the screen. Now, we'll go through the individual panels accessible through the Action panel in detail. First, the Inputs panel. The Inputs panel shows the types of connections available on the device. If a connection has been established, then the source will be highlighted. Otherwise, the source will remain dull. Select any of the connected sources to change the display to that input source. A blue bubble indicates the selected source. For this example, USB-C 1 is currently selected, but the HDMI input has an established connection as well. Therefore, either option can be chosen as a display's input source, or both can be entered into split screen mode by selecting the split screen icon. Once split screen mode is initiated, the screen will look like this. The individual source inputs of each screen are indicated at the top corners of the on-screen display. The active screen will have the device's peripherals connected to it, like the camera, microphone, and/or speakers. As you can see, the L or R symbols on the peripheral button indicate which option is the active screen. Change the active screen by selecting the desired symbol. To exit split screen mode, bring up the Inputs panel and select the preferred input. Please note, split screen mode is currently only supported between devices with the same type of connection. Users need 2 wired connections or 2 wireless connections to take advantage of the feature. For example, a USB-C connection cannot enter split screen mode with a connection made via wireless casting. The next area of the interface is the Settings panel. The Settings panel is divided into several subsections, including Quick Setting, Display, Network, System, Device Information, and Admin. The Quick Settings section is where users can adjust speaker volume, toggle the mic on or off, and change the display brightness. The Display section allows users to change the display setting of the external input sources. These changes will directly affect video rendering, but will not be applied to the Windows Collaboration display system. The values here include contrast, sharpness, colors, and tint. Under the Source Alias subsection, users can rename wired input sources. The Network section displays the current network configuration. Only device administrators can change network configurations. The System section is where users can modify settings like accessibility, date, time, etc. High contrast mode is for users who find it difficult to see contrast in images. Turning it on causes all the white text on the display to be surrounded by a thick black outline for easier reading. The font size slider allows users to change the font throughout the display's interface to a preferred size. This toggle allows users to switch the system time from a 12-hour clock to a 24-hour clock. The next toggle down allows the date and time to be set automatically through an internet connection according to the device's relevant time zone. If the option is turned off, 2 drop-down menus will appear so users can enter that information manually. Further down this section is the Idle Screen Time option. This lets users change the amount of time the system should wait before the display goes into idle mode. User interaction or detected motion will reset the timer. The available time values for this mode in minutes are 1, 3, 5, 10, 15, 30, and 1 full hour. There's also the option to select Never, so that the Windows Collaboration display never goes into idle mode automatically. The Power Saving Timeout option indicates how long the Windows Collaboration display will stay in idle mode before entering Power Saving mode. In Power Saving mode, the on-screen display turns off completely. User interaction or detected motion will reset the timer and end power saving mode. The time values available are 5 minutes, 30 minutes, 1 hour, 3 hours, 6 hours, and 12 hours. There's also the option to select Never, so that the Windows collaboration display never goes into power saving mode automatically. Please note, the power saving timeout value must be greater than the idle screen time value. As a result, changing the time value of one mode may result in the time value of the other mode changing automatically. The language of the interface is also found in this section. A drop-down menu lets you change to any of the supported languages. The options include English, Spanish, French, German, Italian, and Russian. The USB-C video stream value can be set to single stream transport or multi-stream transport. Next is the LAN network setting, which can be toggled on and off. Selecting Bluetooth opens a separate Bluetooth panel. It includes a list of available devices and the option to toggle Bluetooth connectivity on or off. Last is an option to change the system's temperature unit from Fahrenheit to Celsius, or vice versa. Next is the Device Information section. Here, users will find valuable information like the current version of the operating system, the model number, the hardware ID or serial number, and more. The bottom of the section includes options to access the software license, an open source library, and an electronic version of the product manual. The next portion of the settings panel is the admin section. Admin settings require a passcode to access. Users are prompted to create the device passcode during the initial setup. Under Information, admins can edit the device's name. This will change how the name appears on the home screen and on the external devices trying to connect wirelessly. Under the Wallpapers subsection, admins can change the wallpapers through the device's internal storage. Wallpapers can be set for the idle screen and home screen. Next is the Install New Apps button. This enables the admin to install applications customized for the Windows collaboration display. Further down is the System subsection of the admin settings, which includes a variety of features. First, there are multiple drop-down menus to edit the device's location. The options are organized by country, province or region, state, and city. Next is Operation Mode, and it relates to power consumption. The display is set to Mode 1 as a default in order to reduce power consumption, but is set to Mode 2 for the purposes of this module. In Mode 1, the display will automatically switch to network standby mode after 5 minutes of not receiving a signal. The idle screen time and power saving timeout values cannot be changed in this mode. The Wake on LAN, IoT sensor always on, and in-device motion sensor settings cannot be changed in Mode 1 either. Lastly, Mode 1 switches the IoT sensor always on setting to off. Mode 2 enables more features but increases the display's power consumption. Here is where to access the Workspace Intelligence Platform. First-time users will need to enter their provision code to use the service. Next, selecting Sensor Hub will open the Sensors subsection. This is where you can enable or disable the IoT sensors. The real-time sensor values are shown here, including the luminosity value, which is not visible on the Sensor Hub showcase. Please note, the microwave value represents the motion sensor. Next are options to change the user passcode or admin passcode. These options check for and initiate OTA firmware and USB firmware updates. Under that are drop-down menus to set a start and end time, thus creating a preferred firmware update window. Next is the All Reset button. This resets all admin and user settings, thus prompting a slightly expedited initial setup process. Below that is an option to toggle the smart switcher on and off. The smart switcher has the on-screen display automatically switch to the most recently connected external source. This is convenient when connecting multiple devices to the Windows collaboration display. The final options in the admin section of the settings panel include LAN 1, always on connection, Wake on LAN, the IoT Sensor Hub's always on feature, and the in-device motion sensor. Before this module concludes, let's quickly go through the Sensor Hub Showcase. The Sensor Hub Showcase app is built into the Windows collaboration display. It provides a simple demonstration of how the Windows collaboration display can capture, track, and store sensor data. The Sensor Hub automatically starts tracking data whenever the device is turned on. Opening the Sensor Hub Showcase app reveals real-time data values, as well as short timelines of collected data. Historical data can be accessed and analyzed through the Workspace Intelligence platform. Here is the indoor temperature, the humidity, CO2 levels, TVOC levels, and the motion sensor. Congratulations! You've completed Module 3. Please close the presentation to complete this section.